Okay, how to make these card games. First, we need to find them. So we've got the card game here. And it's just going to load. So that's where you can print them from. And I've got a bit of a blah, blah, blah. And so let's have a look at what's down here. All right. So this here is a full set of partially factored two variable expressions. And they're all different, right? So here you have 4 times 2 is 8, so that's 8a plus 8b would be an equivalent expression. Then we've got the 12, the 16 and the 20. But we're looking for like two things the same to make a set because there's no two cards the same. Here we have different formats, expanded and ordered, fully factored, expanded incorrect order and partially factored, but they're all two variable expressions and they're equivalent. You can see the hack is the 8. So it's easy entry for someone who knows nothing about algebra. They're looking for out of this, this, and this, two of them the same. And that's still valid mathematical thinking. And it's about conversation, it's about language, it's about algebra. It's doable. Now, if you're a little bit more advanced, you can be creative with your set creation. So for this example here, you could use a wildcard, and that wildcard could be 8a, or it could be 8 in brackets a plus b plus c plus d. So that's where the students start to debate, is that valid, isn't it valid? And it's up for them, it's up to them to decide. And of course they come and ask you and then you give your expert opinion. But yes, so here we have two equivalent 3 variable expressions, and you can have a wild, but then you have to say, like, what would that other one have been? You actually have to come up with an expression. So it could be 8a plus 8b plus 8c, for example. So we have the 4 wildcards, and then if you look carefully at this, you'll see that first column, they're all expanded and ordered. The second column is all fully factored. The next is all expanded in correct order, and the next is partially factored. So the sets go in rows or columns. So that's kind of the way the cards are set up. So that's 4 fours of 16. Then here we've got another 4 fours of 16 with the sets being in rows or columns. And here, the blue set is different again. Well, it's the same setup, but I've actually got now quadratics. The quadratics are hackable as well by the negative, 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 negative. So you can have those in-depth conversations about the trickiness of all these pluses and minuses. For example, here, when you're doing the FOIL is what we do to expand and then we simplify. So it's really just about them engaging with the maths. And then I've got various different designs for the back. So that's like the linear set. Now if you come back up here before all that blah, 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 you can see once I got started, there was no stopping me. If we look at the linear card game set, it's a similar setup. So crossways, those are 4 different versions of the same relationship between X and Y. And then if you go downways, you've got like the same format. So that's a small set because we've just got the gradient of 0. And then we've got a positive gradient, and that's a bit bigger set, you can see. There's no rules on this. So long as it goes both ways, it's all good. And so here, again, crosswise, if we go for the row, we've got a set of equivalent relationship between the X and the Y. And if we go down, we've got equivalent formats. And then here we've got undefined gradient, and that again is a small set. Now we've got wilds that aren't completely wild. So you can see when you're teaching, you could just take the yellow cards, all the linear graph cards, and actually just have a gradient type exercise, or what's the y-intercept. It's not about the cards, it's about the pedagogy. So that's the big thing really to get one's head around. So if we go to parabola card game, This is one is just ridiculously simple, and I would use it for reading the coordinates of the vertex. This is how I would teach coordinates straight away on a vertex of a parabola, because we've got that little green vertex in there, and you'll notice I worked out after a while that the green dot didn't really go with the orange vertex, so in some of the cards it is actually green. I left it as it is because I think it's all interesting debate. So if we look at that set crosswise, the row, you can see they all have the exact same vertex and they have different shapes. And then we've got the next set of 6. We have got 1, -3 is the vertex, and that carries on to those same shapes. And then we've got 1, 2 is the vertex, and we've got those same shapes as well. So what have we got here? A equals 1, and then that would be A equals 2. That equals A equals -1/2, and that would be A equals 1/2, and that would be A equals -1, and A equals -2. So I want the kids to be able to do this quick as. And then, of course, using the cards, you could have a game where when it's your turn, you put your card up and you say the equation of that graph. If you're right, you get to keep the card. If you're wrong, the other person gets to keep the card. And this way, they're checking each other's work, and I'm activating them as resources for each other. So then you can see I got, in the holidays, I realised that I wasn't actually teaching algebra. When I came back, I was actually teaching statistics. So I decided to, this is before I even realised how well they work, I decided to do a whole lot of statistics ones. And so they are available as well. And you can see I did a similar kind of random as thing. These were really popular with the kids. It got them debating, got them discussing. They sorted them first, then they played Snap or whatever other random game. And look, it's fun. It's good. So make your own set. That's really what I'm doing this video for.